Welcome to the next part of the introduction section, which outlines the course prerequisites and learning strategies. In this part, we'll explain the background students who take this MOOC are expected to have and provide some tips to help students learn the material covered in the videos and successfully complete the assignments. When we teach classes on mobile cloud computing with Android at Vanderbilt University and the University of Maryland, we can rely on the students having taken the prerequisites. In contrast, one of the challenges of teaching a MOOC is that we don't really know what you know and whether you're prepared to master the topics we cover. We developed this MOOC with certain assumptions about and expectations of students who take this course, which are summarized here. To help align our expectations, here are some things we'd like you to know to get the most out of this MOOC. First and foremost, it's essential for you to have a good understanding of object-oriented programming in general and the Java programming language in particular. For example, you need to understand Java features like classes, inheritance, dynamic binding, and generics, so you can follow along with the examples we cover. It's also important to understand core Android programming elements, such as activities, intents, and user interface components, as well as the Eclipse Android Development Tools environment. If you're rusty on these topics, we strongly recommend you leverage resources available on the web, starting with those summarized at this link. In addition to being proficient with Java, it's also useful to understand fundamental object-oriented design concepts, such as encapsulation, abstraction, polymorphism, and extensibility. Object-oriented design is a method of planning a system of interacting objects to solve software problems by specifying crisply defined conceptual boundaries that combine methods and data to hide information likely to change, thereby minimizing rework as requirements and environments evolve, as described at this link. Likewise, knowledge of class and sequence diagrams defined by the Unified Modeling Language, or UML, will help you understand the structure and interactions between key elements of the Java and Android examples we analyze throughout this MOOC. You don't need to be a UML expert to make sense of these examples, but we recommend you read the material on UML available at this link and in other websites and books so you'll understand the notations used in our diagrams. Finally, it would be helpful if you're familiar with common systems and network programming concepts and mechanisms, such as event loops, multi-threading, multiprocessing, synchronization, scheduling, and local and remote inter-process communication. You don't need a deep background in these areas since we'll review them as needed throughout this MOOC. However, if you're interested in learning more about these topics, Section 1 of the 2013 POSA MOOC provides an overview at this link. This MOOC covers a lot of material, and some requires a lot of thinking and practice to master, even if you've successfully completed Professor Porter's MOOC. To help you learn all this material, here are some strategies you should consider when taking this MOOC. First, watch the lectures carefully, perhaps multiple times and at different rates of speed, to fully comprehend the topics that we're covering. Many topics are technically deep, especially concurrency, inter-process communication, and application security. Although we can't possibly address all aspects of this material in our limited time together, you may benefit from learning more about these topics, either during or after this MOOC. Therefore, many slides contain links to articles, documentation, and source code that you can read as time permits. However, no quiz questions relate to this material, so feel free to read it at your leisure. Additional tips for learning the material in the videos appear at this link. Although reading the freely available material online is helpful, more comprehensive information can often be found in the recommended reading list that appears here on the POSA MOOC homepage. I encourage you to read these books to gain even more insights into the material we cover in the lectures. I also urge you to seek out Coursera meetup groups in your area, which are summarized here, where you can get together face-to-face with fellow students and further immerse yourselves in the topics we cover. Another way to make this MOOC feel more like a face-to-face course is to attend virtual office hours, where we'll answer your questions and lead impromptu discussions live via Google Hangout and YouTube. All virtual office hours will also be recorded and uploaded to the POSA website, so you can watch them at your convenience, as described here. Even if you aren't able to join us live, we encourage you to participate in the online discussion forums, where you can interact with other students, post questions, give answers, clarify points of confusion, and learn who else is wrestling with the same challenges as you. We regularly monitor the forums and will provide tips and pointers to mentor you through the learning process. However, there are only a handful of us, but tens of thousands of you. So please read our policies on the forum postings at this link and be respectful of fellow students and staff. In summary, our goal in teaching this MOOC is to help as many students as possible gain access to a world-class education on mobile cloud computing with Android. However, the topics we cover are technically deep and take time to master, so we encourage you to leverage multiple sources of learning, many of which are listed in the FAQ at this link. I strongly encourage you to read the entire FAQ, since it provides a wealth of information to help you succeed in this MOOC. If you're inspired to learn more about mobile cloud computing with Android and associated topics like patterns and frameworks, I recommend you check out the digital learning resources available at this link, which provide dozens more hours of videos and screencasts on object-oriented design and programming with Java and C++, patterns and frameworks for concurrent and network software, and Android middleware and systems programming mechanisms.